All right, everybody. So today we're going to be going through how we're going to be doing a independent samples t-test using both Excel and R. We'll do it in SPSS and JASP as well. So let's get started right into Excel right off the bat. We're going to be doing this one by hand. All right. So what we want to do is we're going to start off by opening up our file that's called RT, or reaction time, for ttest.xlsx. So when we open up that file, it should just look like this. And what you're going to see is two columns of data. And these just are representative of reaction times in milliseconds. What I've done for you here is I've put the equation for calculating a t-test here. And we're just going to show you how we just calculate all these different values. It's actually quite simple when we get down to it. So let's get into doing this. So our first thing is we're going to need our standard errors for both of our values and our means. So in order to get those, we need to calculate our means, standard deviation, and standard error. So I've got those in these three sets of rows in these two columns. So we'll calculate the mean equals average, and it is of B1 through B50. Okay, and I can take that and just drag it over. Okay, so we see I've got my two means already. Done. Standard deviation, we know that one as well, equals STDEV of B1 through B50. And this will be C1 through C50. There we go. And the standard error of the mean, well, calculate that as equal to the standard deviation divided by the square root of the number of samples. In this case, we know it's 50. We can actually just see that. But say we had thousands or we didn't have them in nice rows. A nice way we can do this is by using the count function. So square root of count, however many of these have values in them. So we can see I've got that. There's my new calculation. And again, I can just move that over. Okay, so now I've got my standard error of the mean, 1 and 2. If I like, I can start calculating this out. What is t? T ratio equals mean 1 minus mean 2. Well, let's figure that out first. Equals mean 1 minus mean 2. Great. My mean difference is minus 51.2, right? There's a difference of 51 milliseconds between these two sets. Great. Now I need divided by the standard error of the difference. And that's calculated as standard error of the mean 1 squared plus standard error of the mean 2 squared. And we just take the square root of that. So because we've got the standard error of the mean already, this is going to be really easy to calculate. So standard error of the mean 1 squared, I'm going to put here. And that is equal to this cell to the power of 2. Done. This one equals this cell to the power of 2. Right? So there's those two bits. Let's add them together. Equals that plus that. Great. And we take a square root of all of that. Now that's going to give me this whole bottom function. You can see it's really easy, right? So equals SQRT of this value is 23. Now we can see right away if I want my t ratio is equal to this difference between the means divided by the standard error of the difference. And again, t ratio of negative 2.19. Now, what do you think in terms of whether that's going to be significant or not? Think about how many standard deviations away that would be from the mean. But remember, we're using the t distribution. Think about how many values we have in here. Well, one way we can look to see if this is significant is by using a t-table. And happily, I've put it into this workbook here for you as a second sheet. If I click on t-table, we can see we've got a table of values. Now, The t-distribution of critical values has alpha values for either one-tailed or alpha values of two-tailed. And we're going to be using a two-tailed test at an alpha, or a significance value of 0.05. Now we need to go down to our degrees of freedom. And remember what our degrees of freedom were. In an independent samples t-test, it's the n of group 1 minus 1 plus n of group 2 minus 1. So we know that n of each of these is 50. So 49 plus 49 is 98. So my degrees of freedom is now going to be 98. So I'm going to go into this column and I'm going to scroll down until I hit 98. There's my degrees of freedom. And again, I'm looking in column C. With 98 degrees of freedom, my critical value here is 1.98. So my t-value has to be greater than this value in order for it to be significant at 0.05. And it is. My value, if we go back and we look at it, it's 2.19. We see it's 1.98, so I'm greater than that value. And remember, this only just tells us the direction of the difference between these means. If I did this mean minus this one, I would have a positive number. So don't worry about whether or not it's positive or negative. It just depends on which value you subtracted from the other. So we've got a value that's greater than 1.98. That means we're significant at the 0.05 level. Are we significant at the 0.01 level? Well, let's look in column E. If I scroll down, my critical value is 2.62. Look at my value, 2.19. It doesn't meet that threshold. Therefore, it's not significant at the 0.01 level, but it is at 0.05. Okay, so what we can do is we can say this difference is significant, p is less than 0.05. So of course, there's an easier way to do a t-test in Excel, and that's by using the t-test function. And that is equals t-test, open bracket, and we see it wants array 1, array 2, tails, and type. And it's going to tell us what those are. So let's pick array 1, comma, array 2 is this, comma, and we get down to here, tails. So do we want 1, a one-tailed distribution, or 2 is a two-tailed distribution? We're going to use a two-tailed distribution, so that means I need a 2 in there, comma, what type of test? We know that we're doing an independent samples, so it's not a paired, it's a two-sample equal variance or two-sample unequal variance assumed. Now, there's a little bit of philosophical question as to whether or not you're going to assume equal variance. If we look at our standard errors, they'll look pretty close. We could probably assume equal variance here and just do a 2. And then calculate that. And we get a p-value of 0.03. And that aligns very well with what we saw in our t-table. All right. The last thing I'll show you is if you just did the t-test and didn't want to go through this whole math to get the t-ratio, you can then get the t-ratio by doing a function called t-inv. So inverse t. So it's the t-inv, and it asks for our probability. Well, that's this value here. And our degrees of freedom. And remember that we just calculated that was 98. So if I go 98, what we see here is now I get a nice matching up of my values, 2.1965, etc., 2.1965. So we see we've calculated our t-ratio correctly. All right, so let's get into the other programs to start doing this t-test in those. Okay, so now let's try doing an independent t-test using SPSS. So what we're going to do is use this file up here called independent t-test _ 10km.sav. SAV is the SPSS data file format. So I'm going to double click on that file and open it up, and you should see something like this. Okay, so what we see is our variables are shoe. So we've got either shoe 1 or shoe 2. And in this case, it's shoes versus flip-flops. This is our finishing time in minutes, number of blisters experienced, and then skin temperature of the foot and water loss in liters. One thing I should note is that when we're looking at SPSS, SPSS likes to have each subject in its own row. So note that we can't have a different subject in a different column. It has to be in the long format for SPSS. Okay, so let's do a t-test. So we've got all of this data. All we're going to do is go up to Analyze on the menu, scroll down to Compare Means. And I've got some options. Means, one sample t-test, independent samples t-test. That's the one we want, independent samples t-test. So I'll click on that, and we get a new dialog box comes up. So let's pick our test variables. Let's just pick 1 for now, in minutes, so your finish time. I'm going to put that into our test variable. Now we've also got to select a grouping variable. And our grouping variable is just simply 1 or 2, running shoes or flip-flops. So I'm going to select that and put it into the grouping variable. Note that if I want, I can actually just drag this over as well. Okay, and then you see it's got shoe question mark question mark. I need to define my 2 groups here. So if I click on that, I can say group 1 is 1 and group 2 is 2. Note that it could be anything in here, and you could be testing 2 things amongst a group of 4 or 5 different shoe types if you want to do t-tests. That's why it asks you. Here it's obvious, but in other cases it might not be. So I'm going to say continue. Okay, now I'm just going to click on options to see what I get, and it says confidence interval %, that's what I want, and exclude cases, analysis by analysis, that's fine. If I had missing cases, I might want to select that, but I'm totally fine with this the way it is. I'm going to hit continue and click on OK. All right, so here's the output that SPSS gives me. Now, what we see is we get some basic group statistics, including our N, our mean. This is, remember, our finish time in minutes, standard deviation, and standard error of the mean. Now, we see here is a test right off the bat on this side for Levine's test for equality of variances. And we look again up here, our standard deviation is quite large in one group versus the other. So maybe it's best not to assume equality of variance. And in fact, this test tells me that our variances are significantly different at the level of 0.01. So therefore, what we do is we see we've got 2 whole rows of data here. 1 for equal variances assumed and 1 for equal variances not assumed. So we're going to use the one under equal variances not assumed and look at our output. So now we can forget about Levine's test for equality of variances and look at what we've got. So starting here, we've got our T statistic. So it's -21. And right away, you should know that that's a really big number and it's probably going to be significant. Our degrees of freedom, what we see is that instead of being 18, it's 12.350. So what this does, the equality or the variance is not assumed, it adjusts the degrees of freedom. It penalizes us, making it more difficult to find a significant difference, which is good. We still see that our significance is less than 0.001. So it is a very small number. And then we see our mean difference is 137 minutes, with a standard error of the difference being only 6.45. And we see our confidence intervals of the difference that we get here. But the things we're going to want to report are our t-value, degrees of freedom, and our significance value. We'll get into reporting effect sizes later on, but we can look at those 3 things from now on. Okay, so pretty simple. Let's get on to doing the same thing in JASP. Okay, so let's do a t-test in JASP. So we're going to use this time independent t-test underscore 10km.csv. So let's open that up in JASP. All right, now that JASP has opened up, let's open up that file. Okay, here it is. Now what we see, exactly the same as what we saw in SPSS. We've got our different types of shoes and our finish time. So again, JASP is pretty simple to use. We see our options along the top here, and what we see is one of those is t-tests. So I'm going to click on that, and we can see I've got classical or Bayesian, but we're not going to worry about that right now. We'll just look at classical. And we've got the options of independent, paired, or one sample. And we want independent samples t-test. So we'll click on that. So now what we see is we need to put in a variable and a grouping variable. So this is very similar to SPSS. So let's look at finish time as our variable. And let's put in shoe as our grouping variable. And what we see is we get the same t ratio, -21, with our degrees of freedom of 18, and a p-value less than 0.001. So note, it's given us here, Levine's test is significant at less than 0.05, suggesting a violation of the equal variance assumption. So what we do is we can maybe click on this. And then if we do a Welch's t-test, what we see is that now we have the same correction for the test of equality. So a student t-test is one where the variance is assumed to be equal, where a Welch's test is where the variance is assumed to not be equal. Note that I can ask for descriptives and maybe descriptive plots if I want as well. So we note that JASP is particularly easy to get our values pretty quickly with. Okay, so finally, let's move on and do this same test in R. So in R, I'm going to want to import this file as a new data frame into our file we've been using previously. So let's just open up our previous file using RStudio. All right, and it looks like it's picked up right where we left off. So let's see. The first thing we need to do is we need to import our data set into a new data frame. So I'm going to go up into my environment and click on Import Dataset. From text, I'm going to find the file that I need. Okay, now what we see is it wants a name. So let's give it just a name, maybe just call it t-test 10km. And it's asking, does it have headings? Yes. And then I can click on import. Looks good. All right. We see that it's imported our data just fine. Great. So if I go back to my R script, we're going to say which one of these things I've been using so far is going to work best with what our data is here. And I see that here we had used the library psych in order to work with long data and get descriptive stats. So it's nice. So I'm going to use this chunk, but I don't really need to load this library by actually typing out that command. In fact, I can just go over to this section, click on packages, and select the user library that I want to load. In this case, psych. And we can see that it runs that command for me, which is great. So now I'm going to take this set and I'm going to paste it below because I'm going to be working with a long set of data, and I want to get some descriptives before I run my t-test. So into my data frame, I'm going to attach the new data frame called t-test 10km. Then I'm going to describe by, what are my variables? I think they were called finish underscore time and then by shoe. Okay, so finish underscore time as a function of shoe. Now let's just see if that runs. Okay, great. Now I get my descriptive stats. I've also got a small error down here. Warning message, describe.by is deprecated. Please use the describe by function. All that means is that it's been updated and replaced by a newer function that may have fixed an error or fixed a bug. So we'll just change that. Instead of being describe.by, it'll be describe and then capital by. And I'll do that in my other one, so I don't use that command by mistake again. And we'll see if I run that, I get the same data, but without this error. Okay, great. So we've got our means and our standard deviations, means, all of our descriptives that we want. So now let's simply do a t-test on this. The way we're going to do that is by using, you guessed it, the t-test function. t.test, and we see it comes up here, and I'm going to simply do very similar to this. It's going to be finish underscore time. In this case, using the little squiggle, the tilde, as a function of shoe. Okay, now let's see what happens when I run this. Okay, so what we see is we get our descriptive data, and then we see that it's performed a Welch's 2-sample t-test. And it's done that because the variances can't be assumed to be equal. And we see our t ratio is 21.345. And again, our degrees of freedom are 12.35. They've been corrected. And then we've got a p-value of 4.02 times 10 to the negative 11. So it's still significant to a super high degree. And we can expect that because our t ratio is 21.345. And it will also give us our 95% confidence intervals of the difference. Okay, so the 95% confidence intervals of the difference are 151 up to negative 123, and we see our mean group differences. Okay, and that's all there is to doing a t-test in R. Okay, so hopefully that gets you started doing t-tests in all of the different programs that we've been covering. Now, what you can do is you can go ahead and you can use that independent t-test 10 kilometer and do t-tests now on our different variables. So remember, there was number of blisters and there were other different types of variables, and try and calculate t-tests on those other ones. Okay, next we'll be getting into doing paired samples t-tests.